All right, so we are going to use a graphing calculator to find roots. Oh. Okay, so we're going to sort of write out the steps and do a problem at the same time. So let's enter into our calculators. P of x is equal to 4x to the fourth plus 4x cubed minus 11x squared minus 8x plus 6. Before we enter this into the calculator, can somebody tell me how many roots are we going to have? 4. How did you know they were 4 roots? Good, because the degree of this polynomial, our biggest exponent, is 4, which means we'll have 4 roots. But does that mean they'll all be real roots? No, some can be imaginary. Didn't we talk about that? So some can be imaginary, some can be real. So if not all 4 of them show up, that's okay. Also, what is another thing that can happen? A double root, very good. We can have a double root, meaning it's gonna hit that x-axis, and instead of going through it, what will happen? It will bounce right back up. So let's go into our calculator and see how this looks. Okay, so we're going to type in 4x to the fourth plus 4x cubed minus 11x squared minus 8x plus 6. And then graph. So, not really sure here. This can be a double root, maybe, or it might have very slightly went under, and then back up. So if you want to see if that's a double root or not, what you can do is you can zoom in here. So you can put your cursor over it and then go to zoom and then zoom in and press enter. And then every time you press enter after that, it brings you closer. So even though it had looked like a double root, is it a double root? No. So even though from a distance it looked like a double root, what has actually happened? It went under and then back up. So those are 2 roots right over there. What's up?
How did you zoom in? Because I went zoom and then zoom in.
Enter again.
Yeah.
Were you able to zoom in?
It's like loading. Is yours loading? No. I don't know.
Yours might have just frozen. Do you guys want to see how to zoom in again? So I'm going to go back. So now to go back to the graph, you just press zoom standard. To go back to the original graph, you go to zoom standard. All right, then what you do is you move your cursor to where about you're going to want to zoom in. So I'm moving my cursor to the left. Are you with me? So isn't this where we're about where we want to zoom in on? So then how do I zoom in? You go to zoom, and then you go to number 2, zoom in, enter, and then you press enter again. And then if you want to zoom in again, you press enter again. What if I wanted to zoom in again? What would I press? Enter again. All right, so this is just letting us know this is not a double root. So now what do I want to do? Let's go back to our notes. I'm going to go back actually to Zoom Standard. There's our graph, and let's go into our notes and write some stuff down.
Yeah, how do you know if it was a double root?
If it hit the x-axis and bounced back up. So it looked like it was going to be a double root. Go back to our graph.
I don't know what a double root looks like.
This is what a double root looks like. Do you see how it looks like it hit the x and then bounced back up?
Yeah.
But then when we zoomed in, we realized it didn't just hit the x and bounce back up. It actually went through the x.
That's why it says like -1.1. Yeah, it says like a number instead of.
I wouldn't go by that. It's just physically how it looks. So when you
Right, because I see it and I still think it looks like it just.
No.
I need to go again. Oh, never mind. It goes, yeah.
Do you see it? That's why I said you keep pressing enter to zoom in more to see. Morgan, do you see it? All right. Does everybody see it? Okay. So then to go back, you go to Zoom Standard. So zoom and then 6, and that will bring you back to the whole graph again. All right, let's go to some notes. So what we're going to do is start off by typing in the polynomial. Into the calculator. All right, and then from there, what we're going to do, part B, I want us to find a list of possible rational roots. So this is on the paper. How do we find the list of possible rational roots? What did we call it? P over Q. Very good. So we're going to do P over Q. So this is going to be factors of 6 over factors of 4. So we're plus minus 1, plus minus 2, plus minus 3, plus minus 6. And then for factors of 4, we're plus minus 1, plus minus 2, plus minus 4. If at any point I'm going too fast, just tell me to slow down. All right, so now we're going to get all the different, Leah, what's wrong?
Is the one between the plus minus 2 and plus minus 6 supposed to be plus minus 2?
Oh, that's a plus minus 3. I didn't write the 3 down. Thanks. That's a plus minus 3. All right, so now we're going to combine all the different combinations. So we're going to get P over Q is plus minus 1, plus minus a half, plus minus 1/4. Now we move on to 2. So we could do plus minus 2. But what's 2 over 2? 1. Don't I already have a 1? So I don't need to write again. What's 2 over 4? 2 over 4. Half. Good. 2 over 4 is a half. I already have that. I don't need to write it again. So where am I going over to next? 3. So we're going to do plus minus 3, plus minus 3 halves, plus minus 3/4. And now we go over to the 6. We're going to have plus minus 6. Isn't 6 over 2 3? We already have that. 6 over 4 is 3 halves. We already have that. So this is my complete list of P over Q. Okay, so now what I'm going to do is I'm going to look back at my calculator. So let's write this out. Look at graph. Are there any we can take off the list right away? All right, I'll let you copy that and then I'll go back to the graph. Michael, do you want to tell me?
Plus minus 6.
Okay, good. Just let everybody finish copying and then we'll look at our graph together. Can I go to my calculator? Is everybody done copying? Okay, so let's see what we have. So this is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Was Michael correct? We could immediately take off plus minus 6. Yeah, what else can we immediately take off?
That's the X's.
It's the x's, yep. Dylan?
Everything like above or below, including plus minus 2.
Good. So basically, we can take off, because look, we know this goes down and comes back up, but isn't it between -1 and -2? And then over here again, isn't it between 1 and 2? So we can take off plus minus 1. We can take off plus minus 2. Can't we also take off plus minus 3 since they're over here? All right, so we can take off plus minus 6, plus minus 1, plus minus 2. Let's take all of those off. So plus minus 1 is out, plus minus 2 is out, plus minus 3 is out, plus minus 6 is out. So now we've narrowed it down. Okay, so now what we're going to do, let's write this out. I'm going to show you a way to plug in the remaining ones to see which one gives us a 0. So part D. We're going to go to the second table set.
Salvador.
Nico. My empanada! You're the best. I forgot about it. Thank you. See, he brings me food. Sorry, Nico. Okay, we're going to second table set. It does not matter what the table start is. So then there's going to be a list, and you'll see when we go through this. Table start is usually 1. But this is the important part. We're going to change the independent to ask. This is going to allow us to enter in our own x values. This will allow us to enter in our own x values. Then what we're going to do after that is we're going to go to the second button, then choose graph, or maybe it says table, I forget what it says.
It says table.
It says table, okay. And then we're going to input possible rational zeros. And we'll do this all together. So just write it down so you have something to reference to, but then I'll walk you through it. Are we ready? No? Still copying? I don't think it really matters because we're entering in whatever numbers we want, so it doesn't really matter. Can we go? Okay, so now we're going into our calculator. So what did I say to do? I said to go to second table set. So now we're changing our options here. So second table set. It doesn't matter what the table start is. If we want it to be 0, it could be 1, or 0, it could be 1. It really doesn't matter. We could leave it 0. It doesn't matter. The TBL should be 1. TBL should be 1. And then do you see where it says independent? Yours is probably black on auto. You want to move it so it's blinking black on ask. Press enter. Now what we want to do is we want to go to the table. So we press second, the graph or table, whatever you want to call it. And look what it does. It brings us to a table of X and Y's. And what we're going to do is now we're going to enter in here our list of possible rational roots. So if you guys remember, let's put this on the board. What were we down to? Does anybody remember? What numbers were we down to for our possible rational roots? Plus minus a half.
3/4, 2/3.
That's everything? Okay, so what we're going to do is we're going to enter in. So let's do a positive half. So what you're going to do is you're going to go where it says X equals. And then to type in a half, I'm just going to do 1 division sign 2.
Is it gonna? It was actually 3 halves.
Oh. 3 halves?
Not bad.
No problem. No problem. 3 halves? Okay. So you do 1 divided by 2. Enter. What happens? When X is a half, Y is 0. What does that mean for us? It is a 0. That is a 0. So let's go back here and we're going to say, so we don't forget, X equals a half. These are our zeros. All right, let's go back. All right, so now we did a half. Let's try negative a half. The way you do negative a half, you don't press the minus sign. That will get you an error. Do you see how under the 3 there's that negative sign? We're going to press the negative sign, not the minus sign. So we're going to do negative 1 divided by 2, enter. All right, so when X is negative a half, Y is 7. Is that a 0? No. So let's keep going. So we got rid of the halves. Let's do the fourths. So we're going to do 1 divided by 4, not a 0. So what should we do now? Negative 1 divided by 4. Oh, wait, did we get this down to a degree of 2? I guess we can keep going. It's fine. So then we have, it yields negative, it yields 7.265, not working. So then we got these two. Let's do the 3/4. 3 divided by 4. Again, not working. We'll do negative 3 divided by 4. Not working. And then last but not least are the 3 halves. So we're going to say negative, we'll do 3 over 2. Not a 0. Then do negative 3 over 2. Is that a 0? Yes. So let's go back, write this down. Was it positive or negative that worked? Negative. What is this telling us? I had 2 rational roots, but how many roots should I have altogether? 4. So that means the remaining 2 roots they're not going to be imaginary, right? Because we saw them on the graph, which means they are irrational. So that means they are irrational. So that at this point, let's write this down. Calculator will give you rational roots you must find the remaining roots by hand. But do you see how the calculator sort of chopped our like guess and check synthetic substitution down by a lot. So now we're going to do the rest by hand. So let's set up our synthetic substitution. So with the roots we just used. So the equation was p of x is equal to 4x to the fourth plus 4x cubed minus 11x squared minus 8x plus 6. So we know we have x equals a half and negative 3/2. So I'm going to plug in a half first in my box. So now we are 4, 4, negative 11, negative 8, and 6. Bring down that 4. 4 times a half is 2. 4 plus 2 is 6. 6 times a half is 3. Negative 11 plus 3 is negative 8. Negative 8 times a half is negative 4. Negative 8 minus 4 is negative 12. Negative 12 times a half is negative 6. 6 plus a negative 6 is 0. So now, this would have brought me down to a degree of what? 3. I need it down to a degree of what? 2. So now I'm going to take that other root we found and use synthetic substitution there. So now in my box, I'm going to write 3/2, and we are 4, 6, negative 8, negative 12. Have I lost anybody? Following? Yes, Evie.
I thought the x, the 0 was negative 3.
Oh, was it a negative 3? Oh, that would have changed everything. Thank you. Were you going to say that also? Okay, thanks. All right, let's bring this down. What's up, Augie?
Does it matter like which order we do them in? Like,
no, doesn't matter. So if you did the negative 3/2 first, then the half, you're good. It will get you to the same endpoint, just look a little bit different along the way. So now we're going to do 4. Bring down that 4. So now we're going to do 4 times negative 3/2. Can't we cross simplify that? So 2 goes into 4 twice. So then you're left with 2 times negative 3, which is a negative 6. Negative 6 plus a positive 6 is 0. 0 times anything is 0. Bring down that negative 8. So now we're going to have negative 8 times negative 3/2. Once again, we could cross simplify. 2 goes into negative 8, negative 4 times. Negative 4 times negative 3 is a positive 12. Negative 12 plus a positive 12 is 0. What does this bring us down to? This brings me down to a 4x squared minus 8. Is this a dots? It's a dots? Is 8 a perfect square? No. Is this a dots? No. I do want to factor this though. What can I pull out of here? I can pull out a 4. When I pull out a 4, I'm left with x squared minus 2 equals 0. And now we solve. Can I factor any more x squared minus 2? No, it's not a dot. So now we solve. Can 4 ever equal 0? No, so that's out. 4 can't equal 0. It's not really helping us. So now we have x squared minus 2 equals 0. I'm going to move that 2 over. X squared equals 2. Now we're going to square root both sides. When you square root something, what immediately has to go in front? Plus or minus. So x will equal plus or minus root 2. Those are our last two irrational roots. So our roots. X equals, I think, was it positive a half or negative a half? Okay, thanks. So we have positive a half, negative 3/2, plus minus root 2. Those are our 4 roots. But now what do I want to do? I want to go back and find my zeros. We want to go back and find our zeros. So if we're finding our zeros, we're going to have x equals a half, x equals negative 3 over 2, and x equals root 2, x equals negative root 2. All right, are you ready for this? For x equals a half, I know you're thinking, let's just subtract that half over. But really, when we got to a half, we didn't just subtract the half over, right? Didn't we first add the 1 over and then divide by 2 to get the half? So we're doing the opposite here. We're going to get it to equal 0. So I'm going to first multiply by 2 on both sides. That will cancel out the 2's. So we're going to have 2x equals 1. And then what should we do? Subtract that 1. So it's 2x minus 1. All right, same idea. So these are our factors now. All right, so here we have x equals negative 3 halves. What should I do? Multiply by 2. Good. And then add that 3. So we're going to have 2x plus 3. For these two, can I just subtract that root 2? Yeah, so it's going to be minus root 2. So it's going to be x minus root 2. And what about that last one? What's it going to be? X plus root 2. These are our factors. Ooh. Yes. I did auto, so that means you chose the wrong bathroom. Choose 30's hallway or by South Cap.
I did the South Cap.
Okay. Yep. What's up?
Wouldn't like x squared minus 2 work for the root ones?
X squared minus 2.
So I'm just thinking, because can you just look back?
Yeah, I see what you're saying. We want it down all the way to exponents of 1 on each factor.
Oh.
So like the x minus root 2 and the x plus root 2 would make the x squared minus 2. But we want it down to an exponent of 1 for each of the factors.
Okay.
Yeah.
Is there a difference between the zeros and the roots?
Yeah. Basically, the zeros and roots. No, they're exactly the same thing. Zeros and roots are all the same thing. They're the x-intercepts. Any other questions for me? So I would say let's have you try one on your own, but I don't think we have enough time. So I think we'll end here. You do have homework. It's already posted.